My name is Srilakshmi. My topic is review of probability theory. It's non-random experiment. Here is the introduction to probability theory. Probability theory is a mathematical framework for quantifying uncertainty. It provides the foundations of statistics, data analysis, and various scientific disciplines. Understanding probability involves both random and non-random experiments. There are some key points in a probability. Probability is defined as the measure of the likelihood of an event. Events can be classified as certain, impossible, or contingent based on their probabilities. The range of probability values lies between 0 and 1 individually. Probability symbols used to denote the notation probability of certain events. P of A means the probability of event A happening. P of negation A or P of A complement means the probability of event A not happening. P of A union B means the probability of events A and B happening. P of A intersection B means the probability of events A or B happening. P of A by B means the probability of event A given B. There are types of experiments. Experiments can be classified as random or non-random based on their outcomes. Random experiments have outcomes that are unpredictable and governed by chance. Non-random experiments yield outcomes that can be determined or controlled. True experiments and quasi experiments. True experiments emphasize internal validity, assess cause and effect in relatively artificial environment. Test case a priori hypothesis. Quasi experiments emphasize external validity, describe real, naturally occurring events. Clear or exploratory hypothesis. True experiments participants randomly assigned to experiment or control groups. Participants and experiment blind to assignment. Quasi experiments, non-equivalent groups, existing groups, non-random assignment, participation not blind, self-selection. True experiments, control study procedures, manipulate independent variables, control procedures and methods. Full control may not be possible. Quasi experiments may not be able to manipulate the independent variables. Here is a definition of non-random experiments. A non-random experiment produces results that are not influenced by chance. These experiments often rely on predetermined conditions or controlled variables. Understanding non-random experiments is crucial for applications in various fields. In random experiment, so I take a coin and flip it in the air and let it fall on the ground. If I might be interested in which side of the coin is face up. The most base outcomes on the coin are heads or tails. A random experiment is an option or process that leads to one several possible outcomes. The coin flip is a random experiment. Another random experiment is the time it takes to assemble a computer. The sample space of a random experiment is a list of possible outcomes of the experiments. The outcomes can be collectively exhaustive or mutually exclusive. Examples on non-random experiments. A classic example is a manufacturing process where the quality of products is tested. Conducting a survey with a fixed group of participants is another instance. Controlled laboratory experiments in scientific research also fall into this category. The sample, definition, and examples. Purpose. Researcher chooses respondents trying to obtain as wide a representation as possible. Specific groups for PRS and focus groups. Quota, snowball, start with one or two respondents and ask them to refer you to others. Requirement for cultural experts and resource persons for ethnographic interviews. Matched. To compare two subgroups similar in some ways, units are matched to share as many relevant characteristics as possible. Workshop participants and non-participants for evaluation of forecast views. Convenience includes whoever happens to be around or willing to be interviewed. Importance of non-random experiments. Non-random experiments allow for precise measurement and analysis of outcomes. They are essential in fields such as engineering, social sciences, and medicine. These experiments help to establish the causation rather than mere correlation. Here is a mathematical representation. Non-random experiments can be modeled using deterministic functions. The outcomes can often be expressed as a function of input variables. This allows for predictions and insights based on known parameters. Explain deterministic and non-deterministic. The deterministic algorithm for a given particular input, the computer will always produce the same output going through the same size. In non-deterministic algorithms, for the same input, the computer does not understand what it is actual output. Comparison with random experiments. Random experiments introduce variability and uncertainty into incomes. Non-random experiments provide consistency and replaceability in results. Each type serves a unique purpose in the broader context of research and analysis. Applications in real life. Non-random experiments are frequently utilized in clinical trials for drug testing. They are also employed in market research to gauge consumer preferences. Educational assignments often use non-random samplings method for evaluation. Here is a clinical research. In phase 1, researchers test the safety, dosage, and method of the treatment. These trials are not always specific to a type of cancer. Based on phase 1 trial findings, the drug or treatment is tested to see whether it is effective against a certain type of cancer. In phase 3, randomized testing to compare new treatment with the current standard of care may become the new standard of care. Limitations of non-random experiments. Non-random experiments may not account for external variables that influence outcomes. They can sometimes lack generability to broader populations. Results may be biased if the selection of subjects or conditions is not representation. Strengths and limitations. Strengths. Most laboratory experiments seek to gain informed consent, often a requirement to get funding. Legality. Lab experiments rarely ask participants to do anything illegal. Finding benefits society. Both Milgram and Zimbardo would claim the shocking findings of their research outweigh the harms done to respondents. Limitations: combining random and non-random approaches. A mixed methods approach can enhance the robustness of findings. Random sampling can be used alongside non-random controlled experiments. This combination helps mitigate biases and improve the validity of results. Future directions in probability theory. Advances in computational methods are opening new avenues for analyzing. Non-random experiments will increasingly incorporate machine learning techniques. The integration of big data will enhance the applicability of probability theory. Here is the conclusion. The probability theory encompasses both random and non-random experiments. Understanding the distinctions and applications of each is crucial for effective analysis. By leveraging both approaches, researchers can achieve more reliable and insightful results. Feel free to modify any of the content or structure as needed. Thank you.